Hello everyone, welcome to our additional mathematics past paper questions video. In this video, we'll be tackling four major topics. In Unit 1, we'll have straight lines and linear modulus graphs. In this unit, we will be applying what we learned about length and midpoint of a line segment, equation of a straight line, parallel and perpendicular lines, and graphs of linear modulus functions, and also solving linear modulus equations and inequalities. For Unit 2, which is all about quadratic graphs and linear inequalities, we'll be applying what we learned about solving quadratic equations, maximum or minimum value of a quadratic function, discriminant and nature of the roots of a quadratic equation, solving quadratic inequalities and its applications. For Unit 3, which is all about functions, we'll be applying what we learned on notation, domain and range of a function, inverse functions, and composite functions. Also, for Unit 4, we'll be discussing about what we learned on equation of a circle, simultaneous equations and intersection of a circle and a line, and intersection of two lines. So without further ado, let's move on to our first question. Question 1. The point A has coordinates 1, 4 and the point B has coordinates 5, 6. The perpendicular bisector of AB intersects the x-axis at the point C and the y-axis at the point D. Given that O is the origin, find the area of triangle OCD. So in this situation, we will be finding the area of a triangle, but before finding the area of a triangle, we need to know the base and height of the triangle. And in that case, we need to know the equations of the line for AB and also the equation of the line of the perpendicular bisector that intersects it at the x-axis. So first, we need to find out the midpoint of line AB. Okay. Midpoint of AB. So using the coordinates of AB, A is 1, 4. So applying the formula that we learned. So we need to add the x coordinates, which is 1 plus 4 and divided it by 2. And then add the y-axis, which is 1 plus 5, I should say. 1 plus 5 over 2 and 4 plus 6 over 2. Okay, we get coordinates as 3, 5. So this is the midpoint of line AB. Next is that we need to find the gradient of AB. Okay, the gradient of AB. Now, gradient of AB applying y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we get 6 minus 4 over 5 minus 1. This gives us 2 over 4, which is equal to 1/2. Simplify. And then, since we know already the gradient of AB, we can also find out the gradient of the perpendicular line. Okay, so the gradient of the perpendicular. And in this gradient of perpendicular, once again, we are multiplying the first gradient that we just got, gradient of AB, multiplied to the unknown gradient of the perpendicular, which is equal to -1. So we know that the gradient of AB is 1/2 multiplied to M2, which we don't know, which is equal to -1. We get that M2 will be equal to -1 divided by 1/2, and this gives us -2. So in this case, we can say that, so let's continue this one here. We can say that the equation of the line, okay, equation of the line, let's write it down here. So equation of the line Alright, equation of the line will be equal to, so applying the formula, y minus y sub 1 is equal to the gradient times x minus x sub 1. Alright, so since what we get is 3, 5, we'll apply this. So y minus 5 is equal to m, which is negative 2, times x minus 3. Alright, so let's simplify further. Get y minus 5 is equal to negative 2x plus 6. Rearranging this equation, we'll get y is equal to negative 2x plus 11. To better visualize the problem, maybe we can draw out this one. Let's use maybe another color. So if this is the y-axis and this is the x-axis, okay, so I have y and x. So the coordinates of AB in the originally is 1 to 4. So maybe you can have 1, 2. So this is just an estimate. 3, 4, 5, 6, 7. Maybe we can end there. Okay. And then you can have the y-axis. This is the origin. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there, maybe you can put the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and there, and ending there. So plotting the points that we got so far there. So that's A is 1, 4. So let's assume that it's in this point, 1, 4. And B is 5, 6. Okay, 5 and then 6. So it's around 5. It's around here. Around here. Okay. Now, if we connect these 2 points, this is line AB. Okay, this is line AB. So these 2 points, get point A and point B. Now, we just got the equation of the perpendicular, which is y equals negative 2x plus 11. So in this case, since maybe we can make the lines a little bit more smaller, so you can see clearly the perpendicularity that is taking place here. So it's just an estimate. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 13, 14, 15, and that's it. Maybe you can put 1, 4, and then the other point is 5, 6, 5. Is that 5, 6? Yes, it is. So 5, 6, it's around here. There. Not bad estimate. There. So it's there. So we'll just connect that. And once again, this is our point A and B. Okay, point A and B. And we just got y equals negative 2x plus 11. And in this case, we are actually finding a perpendicular line that is here. Now, there you go, perpendicular line. So in this case, this is the line. This line here is the line that we just got, y equals negative 2x plus 11. Alright, now, in order for us to be able to find the area of triangle OCD, remember, the line AB, the perpendicular bisector of AB, which is y equals negative 2x plus 11, alright, intersects the x-axis at point C, so something here, point C, and something here, which is point D. So if we extend this line, alright, something like that, we will find a point, so which is the x-intercept and the y-intercept. C is the x-intercept, and D is the y-intercept. Okay, in order to find that, so we use y equals negative 2x plus C. So from this equation, alright, so when, let's use another color for this, so when x is equal to 0, maybe you can transfer this part to maybe here. So when x is equal to 0, so y is equal to negative 2 times 0 plus 11. Actually, we don't even need to show this supposedly, but for the sake of discussion, we can say y is equal to 11. So our coordinates is 0, 11. Okay, so we get 0, 11. So I would say this is point D. Alright, this is point D. Okay, this is point D. And when y is equal to 0, so the x-intercept, when y is equal to 0, so we know that y is equal to negative 2x plus 11. So 0 is equal to negative 2x plus 11. 2x is equal to 11. Hence, x is equal to 11 over 2. So point C will get 11 over 2, comma 0. This is our y-intercept. So if we extend this line, although it's not exact, it will touch, what do you call this? 11 over 2 is 5.5, I guess. Yes, 5.5. So it should reach this part. So it may have not be as accurate as we expected it to be, but it's like that. So let's erase this one. So the line will intersect at 11 and 5.5, so something like this. Alright, so point D is around there. So this point, alright, point 11 and 5.5 are the x and y intercepts of triangle OCD. So technically, this triangle OCD. Alright, so maybe we can highlight that part. You can use another color. So the unknown is this area. Alright, this area, the one that I am highlighting in blue. Okay, in blue. So that one. So what's the area of this triangle? Okay, what's the area of this triangle? Okay, let's move this up. So we know that area of a triangle is actually 1/2 times base times height. Alright, so area of a triangle is equal to 1/2 times base times height. Okay, so let's say the length of C from the origin is 5.5. So that's our base. We have 1/2 times 11 over 2 multiply to the height, which is from the origin to point D, which is 11. So times 11. Times 11. And here we'll be getting 121 over 4. Or 30.2 Or 30.3 will be acceptable because in this question, the degree of accuracy was not specified in the question. And if the degree of accuracy is not specified in the question, you have to express your final answers to 3 significant figures. So in this case, anyway, or any equivalent value. So 121/4 or 30.25 or 30.3 are all of the same value. And that's for question 1. Question 2. Alright, so in this case, we'll be applying our lesson. It seems like question 1 is more on Unit 1. And question 2 is more on Unit 2 and 3 and 4. So given that the equation kx squared plus 2k minus x plus k plus 1 is equal to 0 has no real roots, find the set of possible values of k. Now, the key word here is that no real roots, and we'll be applying what we learned on discriminant. So I'll be writing it here. So if the b squared minus 4ac, which is this discriminant, if the discriminant is greater than 0, we know that this should have 2 roots, okay? 2 real roots, okay? 2 real roots. And if the discriminant b squared minus 4ac is less than 0. Oh, sorry, I didn't write that down. Alright, is greater than 0 here. Okay, so if it's less than 0, there's no real root, which is actually the question here. And if the discriminant value is equal to 0, b squared minus 4ac is equal to 0, then we have 1 real root. Alright, now let's continue solving. I'll be using black to show our solution. So the given equation is kx squared. Alright, let's copy it out again. So kx squared plus 2k minus 1x plus k plus 1 is equal to 0. So it means from this equation, our a value is k. So let me just write it down. A is equal to k. And 2k minus 1 is b. Alright, 2k minus 1. And our c, alright, is k plus 1. Now we just need to plug in these values in our discriminant. And it has to be less than 0. Okay, less than 0. So we can get b squared. So 2k minus 1 squared minus 4 multiplied to k for ac and times k plus 1 is less than 0. Alright, now we expand. So get 4k squared minus 4k plus 1 minus 4k squared minus 4k is less than 0. So as you can see here, 4k squared and 4k can cancel out each other. So cancel. And we're left with negative 4k plus negative 4k will get negative 8k plus 1. Okay, plus 1 is less than 0. Or negative 8k is less than negative 1, or k is equal to 1, is greater than 1 over 8. So remember, when you are dividing negative to both sides of an inequality, you flip the sign. you flip the sign. So you get k is equal to, k is greater than 1 over 8. So find the set of values, find the set of possible values of k. So I think this one are the sets of values of k. So if we, I think this is enough. So if you want to draw it out, so it's also fine. Okay, it's also fine. So in the number line, all right, so if this is k, so 1 over 8, right? So let's say this is 0, and then this is 1. So let's say this is 1 over 8. 1 over 8, 0 point something. So let's assume that it's around here, 1 over 8. So it's greater than that. So going there, all the values going to the right, going to the positive infinity, are the possible values of k. So k is greater than 1 over 8. Alright? So I hope you understood that. Now for question 3. So for question 3, is related to modulus graphs, I guess. So still unit 1 and inequalities. So draw the graphs of the modulus y is equal to the modulus of 2x minus 5, and y is equal to the modulus of 4 minus x for x is greater than or equal to negative 2. Alright, that's a domain, but less than or equal to 6. So for it to become a one-to-one function, we need to limit the domain. That's for 3a. Alright, so let's start solving it. So it's drawing, and when it comes to this kind of questions, guys, you have to make sure that you have to use your pencil so you can submit a neater or cleaner workings to Cambridge. And same with the during examinations, and especially when you want to erase, you'll be able to erase. Especially, you're not allowed to use correction tape in this test. Alright, so we have the first equation, which is y is equal to 2x minus 5. So when we solve this, we assume that it's still a straight line first. So y is equal to 2x minus 5. Then we get the x-intercept. So the x-intercept, we let y is equal to 0. Okay, let y is equal to 0. So that's 0 is equal to 2x minus 5. Hence, 2x or x. So from here, we can say x is equal to 5 over 2. Okay. Now for the y-intercept, okay, for the y-intercept, we let x equal 0. So y is equal to the modulus of 0 minus 5. Okay, 0 minus 5, because 2x minus 5, right, is equal to the modulus of 5, which is equal to 5. Alright, there. So those are the equation. On the other hand, we have the other equation, which is y is equal to 4 minus x. I will use another color for this. Okay, y is equal to 4 minus x. And we'll do the same thing. We get the x-intercept and y-intercept also. So to get the x-intercept, okay, once again, we let y is equal to 0. And 0 is equal to 4 minus x. Alright, so x is equal to 4. And for y-intercept, okay, we let x is equal to 0. Okay, so we get y is equal to 4. Okay, y is equal to 4. So 4 minus 0 is 4. So y equals 4. Now, plotting these points on the graph, so we have for the first line, which is y is equal to the modulus of 2x minus 5. So we have 0, 5, so that point, 0, 0, 5, okay, 0, 5, so this point, okay, that point, and maybe this is too thick, let's make it thinner, so 0, 5, And we have the other line, which is 5 over 2, 5 over 2 or 2.5. So it's around here. Let's label this line. Okay, so let's use black. So these are 5 over 2, and this is our 5 or 0, 5. Okay, 5. Let's connect this line. So it's a modulus 1, so we need to extend as far as we like. There. So that's the first line, and then we just need to reflect. We just need to reflect. It's around here. Okay, so that line. And then we also plot the points for, okay, let's use another color for this. Okay, let's use another color for this. So we have 0, 4. Okay, 0, 4. So it's this point. And 4, 0. Okay, connecting these 2 points. Alright. Connecting those 2 points, and we reflect it around here. Oh, here. Yep. So there you go. So we have the first line, the modulus of y is equal to, so I can write it down here. So y, this line, the black one, y is equal to the modulus of 2x minus 5, and the purple one is equal to y is equal to the modulus of 4 minus x. Alright, so that gives us the 4 marks, guys. So getting the x and y intercepts and then plotting correctly the given lines. Now for question B, use your graphs to solve the inequality 4 minus x is less than or equal to 2x minus 5. Alright, so if it's less than or equal to, meaning like we'll be actually finding the set of points that are below the 2x minus 5. Now, if you take a look at the points of intersection of the two lines, so we have this. Let's use another color for that. So, orange. So, in this point as well. Those are the points of intersection. Okay, so if we draw out a line going down there, so that's 1 and 3. So, those are the critical points. Now, if we take a look there, the set of points that are under y equals the modulus of 2x minus 5, the set of points that are going there are the ones going to the left. Okay? The ones going to the left of that 1. So, x, we can say that x is less than or equal to 1. On the other hand, for the critical point, which is 3, so the set of points that are under the black line are this, something like the set of points that are here. Hence, x, okay, x, so going to the right, so x is greater than or equal to 3. So for letter B, we can say x, alright, x is less than or equal to 1, or x is greater than or equal to 3. So that's 2 points. Alright, so that's for question 3. Now let's proceed to question 4. Now for question 4, it's the same with question 3. Alright, so on the axis, sketch the graph of y is equal to the modulus of 4x minus 6, showing the points where the graph meets the axis. Alright, so meaning like the x and y axis. So it's easy. So easy to marks. So we'll just do the same thing with what we did in the previous question. So get y is equal to 4 minus x, and then we'll get the x-intercept and y-intercept. So x-intercept. Now once again, we let y is equal to 0 here. So we get 0 is equal to 4 minus x, Hence, wait, why 4 minus x? 4x minus 6, my apologies. So the question is 4x minus 6. I didn't see that. So let me copy the correct question. So 4x minus 6. 4x minus 6. So in this case, 0 is equal to 4x minus 6. Okay, so we get 4x is equal to 6. X is equal to 3 over 2. 6 over 4 is 3 over 2, or 1.5. Okay. Now, we get the y-intercept. Okay, we get the y-intercept. Y-intercept, we let x is equal to 0. So, get y is equal to the modulus of 4 times 0 minus 6. And we'll get the modulus of negative 6. Hence, we get equal to 6. Okay, so y is equal to 6. Now, we have our set of points. Okay, we have our set of points. So in this case, since you're using a ruler, it's better if you use the centimeters, or a more accurate way of representing the set of points that you just got. So in this case, I will just estimate. For the meantime, I don't have a ruler here, so we get 0. So we get 1. Okay, we get 1. 1.5, so maybe I'll put 2 here. Okay, then we have 3 here. Okay, and then for y-axis, what's the point? 1.506. So I can have estimate 2, 4, and then 6. This is 8. Okay. Now, we can now plot the points. So we have 0, 6. So from this point, let's make it a bit larger. So there. 0, 6, and 1.5. So it's in the middle of 1 and 2. Okay, so let's connect those 2 points. Alright, there you go. Now, to reflect this, you can actually reflect this like 1.5, then until 0.5. You can just make it like this. It's around here. Okay, and I think that's it. Maybe you can select 2. If you don't like, you can select, if you want to be more accurate, instead of estimating this, you can also select any points on the line that you just shown. So for example, at x is equal to 2, something like that, we can substitute. So y is equal to the modulus of 4 times 2 minus 6. Just to have a better drawing, y will be equal to 4 times 2 is 8, minus 6 is 2. So y is equal to 2. So in this point, you can select, so it's around here, there, although it's not accurate. So, so you can have around here. It's not a perfect absolute V graph. So around, maybe the point is around here. So okay, there, something like that. Okay, so it may not be exact here, but it should look like that because it's an absolute value graph. Okay, so just draw by accurately your 2, 4, 6 points, and the scale properly your x and y axis. But then showing this working would make your drawing more accurate. Alright, for letter B, solve the equation, the modulus of 4x minus 6, which is equal to the modulus of 2x. So we can say that in here, we'll use green as well. So we get 4x minus 6 is equal to positive and minus 2x. So those are the two values. So 4x minus 6 is equal to positive 2x. In this, we get 2x is equal to 6. So 4x minus 2x is 2x. Move negative 6 to the other side, we'll get 6. Hence, x will be equal to 3. Okay? Now, another, when 4x minus 6 is equal to negative 2x, alright? So you get 6x is equal to 6. Hence, x is equal to 1. And I think those are the answers already. On the other hand, if you want to solve this in another way, there's also another way. Okay, there's also another way. Okay, so or in this manner, we can square both of the given expression on both sides of the equal sign or the equation. So you get 4x minus 6, square it, is equal to square of 2x, or 2x squared. So expand this one, you get 16x squared minus 2 times 4, 8 times 6 is 48, so minus 48x, plus 6 times 6 is 36, which is equal to the square of 2x is 4x squared. Now, combining like terms, 16x squared minus 4x squared will get 12x squared minus 48x plus 36 is equal to 0. Now, if we take a look at the coefficient of all terms in this quadratic equation, they are all divisible by 12. So dividing both all the terms by 12 will reduce this to x squared minus 48 divided by 12 is 4x, and 36 divided by 12 is 3 is equal to 0. And in this case, it's easier to factor instead of using the very long quadratic formula. So in this case, AC method, so x squared can be factored out to x and x. And factors of 3, it's easy because it's a prime number, okay, plus 3. So that's just and 1 and 3. And since the middle term is negative 4, negative 1 and negative 3 would be the factors. X, this is negative x minus 3x, combine them, it's equal to negative 4x. So this one is found in the middle term. Therefore, the factors are x minus 1 and x minus 3. So you get x minus 1 multiplied to x minus 3 is equal to 0. Hence, x is equal to 1, or x is equal to 3, which will give us the same answer with the first method. And that's how we solve the given equation. Okay, so that's for question 4. Question 5, okay, it's all about function, which is unit 3, alright. So question 5, write 3 plus 4x minus 2x squared in the form a plus b times the quantity of x plus c squared, where a, b, and c are integers. Now remember this form. Okay, let's use another color for this. So this form is the vertex form, okay? The vertex form. And when we speak about vertex form, we need to apply our knowledge on completing the square method. Okay, so we have vertex. Okay, vertex form. And we need to apply what we know on completing the square. Okay, completing the square. Alright, so let's have the first method. So get 3, rearrange this quadratic equation, expression, in a form of ax squared plus bx plus c. So we'll get, negative 2x squared plus 4x plus 3. Alright, now we apply our knowledge on completing the square. So get negative 2, factor out, get x squared minus 2x plus 3. And then once again, we get the half of the middle term, the coefficient, which is 2 here, and then square it and add it on both sides of the equation. So remember that. So the middle term, so for the middle term, alright, that's negative 2, right? Negative 2. So we get negative 2. And that's negative 2, get the half of it, which is you divided it by 2. And this is equal to negative 1. Square it, we'll get 1. So we will add that on both sides of the equation. In this case, the equal sign is on the left side. So I would just want you to use your advanced knowledge on like transposing a number on both sides of the equation. So what will happen here is that we get negative 2 multiplied to x squared minus 2x plus 1, plus 1. And then we subtract it also because we moved the other 1 on the other side of the equation. And then plus 3, So I hope you get this part. It's very important. And then get negative 2, alright, x squared minus 2x plus 1. Now, if we multiply negative 2 times negative 1, so this is a perfect square already. Negative 2 times negative 1 is positive 2. So I will put that outside of the equation, plus 2 plus 3. So we'll get negative 2. Now, since this is a perfect square, which is actually x minus 1 squared plus 5. And if you take a look here, we can now transform it in this form. So we can get 5 minus 2 multiplied to x minus 1 squared. And this is already the answer. This is already the answer. So let's just move it on the better left side. So let's just put it here. Alright, so that's for 5A. That's for 5A. Maybe I will propose another way of solving this. So I just had in mind this way. And maybe for others, this will be more convenient. So once again, we have negative 2x squared plus 4x plus 3. Now we'll get negative 2. Factor out negative 2. We'll get x squared minus 2x. Now, the middle term of this is 4, right? So, half of 4 is 2. Negative 2. So, to get the half of 4, which is 2, so get minus 3 over 2. Minus 3 over 2. Oh, I forgot to write 2 here. And then get negative 2. So x squared minus 2x minus 3 over 2. So the half of negative 2 is 1. So just like what we get in the middle term here. So we'll apply that. So get x squared minus 2x plus minus 1 squared. Minus 3 over 2. Minus 3 over 2. squared minus 2x minus 3 over 2. Wait, x squared minus x squared. Okay, so from here, I would say, from here, we can get x minus 1, okay, because the middle term is x minus 1 squared, minus 1 squared, alright, minus 3 over 2. So in this case, like, we're applying the middle term, okay, alright, and then we'll get negative 2, okay, the perfect square x minus 1 squared minus 5 over 2. Okay? 1 squared is 1. Minus 3 over 2 will give us minus 5 over 2 or negative 2 over 2. Moving on, we'll get negative 2. Okay? So get x minus 1 squared. Okay? Plus 5. Okay, plus 5. Why is that? Cancel out 2. Okay, and then we'll get 5 minus 2 multiplied to x minus 1 squared. Alright, so that's also another way on how we can find out the answer for letter A. Now for letter B, hence write down the range of the function f of x is equal to 3 plus 4x minus 2x squared, where x are all sets of real numbers. So again, if we go back to what we've learned again about the value of a, so again the general equation for of a quadratic equation is ax squared plus bx plus c. When a is greater than 0, the graph opens upwards. When a is less than 0, the graph opens downwards. And in this case, the value of a is negative 2, which is less than 0. So we expect that the graph is actually opening downwards. It opens downwards. Okay? Now we're finding the range. Now since we already have wrote the given equation in a vertex form, okay, the vertex form, which is 5 minus 2 times x minus 1 squared. Okay, so the value of h and k, okay, h and k is 1 and 5, which is the maximum point. So we get 1. So from here, so I dotted it by green, it's 1, 5. Okay, 1, 5. Hence, the range of the function is f of x is less than or equal to 5. And that's for letter B. That's why it's only 1 mark. So you need, as discussed, it's actually a good application of the vertex form of quadratic equation. So you will be able to immediately spot the vertex or the minimum or maximum point or the turning point of the given equation, quadratic equation. All right, so let's proceed to the next question. Question 6. Use algebra to show that the equation 5x multiplied to x minus 3 is equal to 5x, okay, 5x minus 26. 5x minus 26 has no real solutions. So going back to what we've had in the previous question, we'll apply what we learned here. So b squared minus 4ac less than 0 has no real root. So that should be, we'll apply it here. So we get 5x minus x minus 3. So 5x multiplied to x minus 3 is equal to 5x minus 26. So expand, we get 5x squared minus 15x is equal to 5x minus 26. Okay? Now, combining like terms, we'll get 5x squared minus 20x plus 26 is equal to 0. Okay, so we get 5, 20, and 26. They have no common terms, so that's it. So we get 5b squared minus 4ac, alright, should be less than 0. Okay, less than 0. So let's see. So we'll just need to show. Okay, we'll just need to show. Oh, it's show. Okay, show. So we need to show workings. So our a here, so a is 5, b is negative 20, and our c is 26. So we get negative 20 squared minus 4 multiplied to 5 times 26. Okay, so we'll get 20 squared, typing this in calculator, we'll get negative 120, which is less than 0. Therefore, it has no real solutions. Okay, it has no real solutions because negative 120 is less than 0. Or maybe you can just write here shown, because you have proven it that it's actually less than 0. And that's 3 marks already. For question 7, okay, for question 7, so find the exact distance, okay, the exact distance between the 2 points where the curve 9 multiplied to the quantity of x minus 1 squared plus 4 times the quantity of y minus 3 squared equals 36 cuts the y-axis. Okay, cuts the y-axis. So this topic falls on the 4th unit. So circles and simultaneous equations. Okay, circles and simultaneous equations. So let's have letter A. So for letter A, we have here, it cuts the y-axis. So the keyword that we have is it cuts the y-axis. And when we say cuts the y-axis, x is equal to 0. That's the clue we have here. So we plug in 0 into the given equation and we'll get, okay, we'll get 9 multiplied to 0 minus 1 squared plus 4 multiplied to y minus 3 squared is equal to 36. Okay, is equal to 36. So get 9 times 1 is 9. So get 9 plus 4. So expand this one, we'll get y squared minus 2 times y times 3, we get minus 6y plus 9 is equal to 36. Okay, is equal to 36. Now moving on, we get 9 plus 4y squared minus 24y. 9 times 4 is plus 36 plus 9 minus 36 is equal to 0. Okay, now simplifying this further, so 36 minus 36 is just cancelled out. So this one, we're left with 9. 9 plus 9 is 9 plus 9. Okay, so 9 plus 9. Okay. So it should be done here. Oh, so we have the 36 already, so minus 9 is equal to 0. Simplifying it further, alright, so there's so this one should be plus 36. Okay, plus 36 is equal to 36. Okay, so is equal to 36. So if we move 9 plus 4y squared minus 24y plus 36 minus 36 is equal to 0. Now this one will cancel out each other. So we're left with 4y squared minus 24y plus 9 is equal to 0. Okay. So our A, B, and C, 4, 24, and 9 is no common. There's nothing common to them. So we'll get the A. This will be our A. This will be our B. And this will be our C. And let's use quadratic equation to solve this. So we get y is equal to negative b plus minus the square root of b squared minus 4ac over 2a. Alright, so plugging in the values that we get, so we get negative 24, negative of negative 24. So plus minus, so square of negative 24, okay, squared, minus 4 multiplied to 4 times 9. So don't forget to extend your square root there, then 2 times 4. Alright, so continuing it, we'll get 24 plus minus the value of the discriminant, which will be, so 24 squared minus 4 times 9, we'll get 432 over 8. Alright, so there are two possible values of y here. So y, so the y sub 1, or the first value of y, will be equal to 24 plus the square root of 432 over 8. Y sub 2, and we'll get the value of this one first. We'll get 6 plus the square root of 6 plus 3 times the square root of 3 over 2. Okay. Now for y sub 2, we'll get 24 minus 432 over 8. And y sub 2, okay, y sub 2 will be equal to 6 minus 3 square root of 3 over 2. Alright, so remember the question here is that the 2 points that cuts the y-axis. So to find the distance between the two y values, so to illustrate it clearly for everyone, let's say we have a circle. Alright, we have a circle. And the 2 points that are actually here, so let's say in here, alright, so assumingly like that. So it's in here, 2 points. Let's just estimate. Okay, let's say this first point is your y sub 2, and this is your y sub 1. Now, to find the distance between y sub 2 and y sub 1, we just need to subtract them. Okay, we just need to subtract them. So distance between them, okay, distance between them will be equal to 6. 6 plus 3 square root of 2 over 2. Alright, this quantity, subtract it to 6 minus 3, the square root of 3 over 2. Okay, plug this in your calculator and we'll get 3 square root of 3. And that's the distance between the 2 points where the y cuts the y-axis. Okay, where y cuts the y-axis. Now, moving on for letter B. Okay, letter B. Find the coordinates of the points where the curve with the equation 2x squared plus 83xy is equal to x cubed y minus 20x intersects the curve with the equation y is equal to 1 over x. Give each of your answers in the form a plus b square root of c, where a and b are rational and c is the smallest integer. Okay, and c is the smallest integer. All right, so let's find out. All right, so we have the equation 2x squared. Let's just another, okay, 2x squared. Okay, 2x squared plus 83xy is equal to x cubed minus 20x. Okay, to solve this, we just need to plug in the value of y, which is 1 over x, into this equation. So we have 2x squared plus 83x times 1 over x, which is equal to x cubed. Okay, wait for a while. I missed writing y here. So x cubed y. So 1 times 1 over x minus 20x. Okay, so moving on, we'll get 2x squared plus 83x times 1 over x will give us 83. So 83 times 1 is plus 83 is equal to x cubed times 1 over x will give us x squared minus 20x. Okay, minus 20x. Now, rearranging this equation, we'll get x squared. 2x squared minus x squared will give us x squared plus 20x plus 83 is equal to 0. Now, 1, 20, and 83 has no something in common to them, so we'll use quadratic formula to solve this again. So, x is equal to negative b plus minus b squared minus 4ac, alright, over 2a. Okay, over 2a. So let's put this formula a little bit. Okay. So there. Alright, so plugging in the values that we have from the quadratic equation, we get negative b, that's negative 20, plus minus the square root of b squared, so 20 squared, minus 4 multiplied to 1 multiplied to 83. Okay, over 2a, which is 2 times 1. Okay, 2 times 1. And we'll get negative 20 plus minus, so the value of the discriminant. So 20 squared minus 4 times 1 times 83 will give us 68. Okay, 68 over 2. Okay, over 2. 2 times 1 is 2. Alright, so we get x. Okay, x is equal to negative 10 plus minus the square root of 17. Now, we know that this one is not yet simplified because if our answer has a surd or square root on the final, we need to rationalize our answer. So, to get y, so y is equal to, maybe let's put it on the other side of the solution space. So, here, so let's just copy this one out. Copy. Base. So let's put it down here. So from here, okay, so get y is equal to 1 over, because it's negative, 1 over negative 10 plus minus the surd of 17, multiplying that to negative 10 plus minus surd of 17, same, negative 10 plus minus surd of 17. We'll get y is equal to negative, cancel out, you get negative 10. Okay, so you get negative 10 over 83 plus minus square root of 17 over 83. And this is our answer. So that's how we're going. So in this, we now have the following that form. So that's how we solve this question. And thank you guys for listening. May this video help you to prepare for your exams. Thank you.